biological networks and imported omics data in Cytoscape, it is important to visualize the data sets in a certain network context, which may reflect certain design principles or biological processes, such as network motifs and modules. Omics Analyzer enables biologists to examine behaviors of the imported omics data sets in specific network contexts. We do this by providing two steps of operations to fulfill such an analysis. First, the user selects a certain network context of interest through which to manipulate the parent network. Second, the user selects a certain chart style to visualize the imported omics data set on the network context. In this example, we use a yeast network and multiple omics data sets as a use case. We're using two yeast data sets that were published in the journal Science. First, we must create a subgraph of interest. We built this subgraph out of the yeast network. Omics Analyzer provides a function to manipulate the parent network from various topological perspectives through plotting visualization in network. Through this panel, the user can select the network context of interest, which reflects the network of different levels of detail. There are three network operations a user can choose from in this panel. If the user is interested in the entire parent network as a network context, the user can select all nodes in the network through the button All Nodes in Current Network. Or, if the user is interested in a certain part of the parent network as the network context, you can select it through dragging your mouse on the Cytoscape network panel, and then click the button Drag on Current Network. Or, the Omics Analyzer can offer you a flexible interface to enable you to invoke other third-party Cytoscape plugins, which are dedicated to network topological analysis. Use the button Subnetwork using Subgraph Creator. Different plugins can give different modules and subnetworks. Using these plugins, we can create a wide range of different types of subnetwork contexts, such as feedback loops, cycles, dense modules, hubs, paths, and shortest paths.